Okay, you all know me, so you don't need to see my face before I start this. And one of your classmates was Jared was just in, and we kind of had one of those aha moments for this Lenz's law thing. Let's go back and look at Lenz's law, and it says this: the induced EMF, in other words, the voltage, resulting from a changing magnetic flux. All right, you know what a magnetic flux is too. Here's a magnetic flux right here that's changing. You got the BA cosine theta minus the BA cosine phi over delta t times the number of turns in a thing. It's the change which causes the in the flux, which causes the which induces the current. Okay, and that current that leads to an induced current whose direction is such that the magnetic field that it makes, is what this is saying, opposes the original flux change, right? And so what we came up with, right? So there's Lenz's law. So here's what we came up with, and I used to bring in a sleeky, but you all may bring in, your you may bring in a styrofoam cup like this. And then all you need to do, watch this. This is amazing. This is really amazing. All you need to do is draw your current on the darn thing. Here's another cheat sheet thing that you can bring. Here's I. Here's the induced current. Here's the direction of the induced current. Okay? Because you know why? Because look, remember right hand rule 2? You take your left hand, your left hand, and your thumb is in the direction of the current. Fingers are this way. So I've got a current going in. So I've got a magnetic field going in. Current going around, magnetic field going in. Hey, what happens if the magnetic field's going the other way? And the current's going the other way. That's simple. So let's take a look at what's going on here. Let's take a look at the induced. That's all there is to it. All right, so here we go. We've got a uniform magnetic field. All right. Uniform magnetic field, and it looks like this. All right, so there's our uniform magnetic field. Now, let's start dragging this guy through here. And let's figure out which way the current's going to go in this thing. All right. So as we're coming this way, the magnetic field is going into the page, and it's increasing as I'm sliding along like this. The magnetic field starts off low, and then I'm sliding along, so the magnetic field is increasing. So I'm going to induce a magnetic field that's going to change. And here you go. If I'm drawing the current if I've drawn the current going like this, look. Here's your right hand rule number 2 thing. The B field's going that way. If the current's going that way. So if the current's going the other way, my B field's going up. All right, so look. So here's what's going on here. Current's getting big. The magnetic field's getting bigger. It's going to induce a current that is going to change. It's going to induce a current that is going to change. That's going to go in the opposite direction of the change. The change is getting bigger going down, so I need a current that's going up. So I need a magnetic field a current that's going to induce a magnetic field that's going up. Oh, so now I need to flip my magnetic fields going in the other direction, and look what I get. I get the magnetic fields going around this way. It's going around the cup. If you can see that, it's going around the cup this way. All right, so now keep your eye on the magic cup here. Now, as I'm sliding out this, so in here, let's make this magnetic field a little bigger. So now, as I'm sliding, so when I'm in here, what's the current? 0. There's no change. Now I'm starting to pop out the other end. Here I'm going to come along. Oh, I'm popping out the other end. So the magnetic field that's going into the page is getting weaker. It's getting weaker. So I need a magnetic field that's going to oppose that change of it getting weaker. In other words, I need a magnetic field that's going into the page because the into is getting smaller and that's the change is getting smaller. So due to conservation of energy, one of the questions on the exam, one of the conceptual ones, it's going to create a magnetic field going that. Oh, so if my B field needs to go in, then my current's going to go the other way, this way. Cool? You may bring a styrofoam cup marked like this, okay, as part of your arsenal. Just kind of like you can bring, you know, some of your Legos to a chemistry test. I know they're not Legos. Don't get mad. All right, out here. We are done.